Over the course of science, individuals have attempted to comprehend how the universe began. The most well-known explanation has been something referred to as the theory of how things came to be. Many investigations and the work of thousands of researchers support this idea, providing evidence about how the universe began. However, in today's world of science, new technology brings us novel ideas and perspectives. These filamentary structures, known as the cosmic web, and the presence of these galaxy clusters in the cosmic web design, strongly support the theory of the Big Bang. The way galaxies are distributed across the universe aligns with the gravitational effects predicted from the early dense and expanding state proposed by the theory. These factors, including the clustering of galaxies, the cosmic web structure, and the distribution of galaxy clusters, provide strong evidence that the universe evolved from a very dense state and has been expanding over billions of years. Now, we should return to the size of the galaxies discovered by the James Webb Space Telescope. These images contradict what we thought we knew about the theory of how things came to be. According to the theory, small galaxies should grow and expand through collisions and merges with other galaxies. However, observations made by the James Webb Space Telescope have cast doubt on this idea. If galaxies were colliding and merging as expected, we would see evidence of these impacts or marks in the interacting systems. Yet the images show something different. So, is the theory of the universe's origin just an idea without proof? No, it is still supported by convincing evidence, including observations of the redshift of light. Evidence from distant galaxies supports the expanding universe theory, with observations showing galaxies moving away from each other, suggesting continuous expansion as predicted by the theory. The abundance of light elements like hydrogen and helium found throughout the universe is also consistent with the Big Bang theory's predictions. Furthermore, the large-scale distribution of galaxies revealed through cosmic surveys matches the structures predicted by the Big Bang theory. One of the most significant pieces of evidence for the Big Bang theory is the discovery of the cosmic microwave background, CMB. The CMB is faint radiation that fills the entire universe and represents the afterglow of the Big Bang. This cosmic radiation, first detected in 1965, aligns closely with the predictions made by the Big Bang theory. The observed characteristics of the CMB, including its uniformity and temperature distribution, strongly support the idea that the universe was once in an incredibly hot and dense state before undergoing expansion, a central component of the Big Bang theory. The discovery of the cosmic microwave background is a crucial piece of evidence that offers us a unique glimpse into the early moments of the universe. It acts as an echo of the initial stages following the Big Bang and has played an essential role in solidifying the Big Bang theory as our best explanation for the origins of the universe. However, recent findings have challenged some aspects of the Big Bang theory. The presence of galaxies with ages that seem to predate the Big Bang contradicts the theory's key premise, suggesting that the Big Bang may not have occurred as originally thought. Furthermore, everything may not have begun with it. Advocates of the Big Bang theory had predicted that as the James Webb Space Telescope looked deeper into space and further back in time, the number of observable galaxies would decline, eventually leading to a cosmic dark age. However, recent research shows that even 200 or 300 million years after the speculative Big Bang, galaxies as large as our Milky Way were common. The James Webb Space Telescope images reveal a much greater abundance of massive galaxies at redshifts greater than 10 than what scientists had anticipated, challenging the validity of the Big Bang theory. Additionally, the Big Bang theory is associated with several inaccurate predictions in the current body of scientific literature, with only one accurate prediction regarding the abundance of deuterium, a form of hydrogen. Some of these inaccurate predictions include estimates of helium overabundance, which are off by a factor of 2, and predictions for the abundance of lithium, which are off by a factor of 20. The theory also fails to explain other phenomena, such as the absence of the expected distortion where objects should appear smaller with increasing distance. These discrepancies raise concerns about the validity of the theory of how things came to be. By studying the colors of distant galaxies in the infrared part of the spectrum, astronomers can estimate the ages of the stars within these galaxies. Some of these galaxies appear to have stellar populations that are more than 1 billion years old, contradicting the theory's assertion that nothing should have existed before the Big Bang. Despite these significant discrepancies, it's important to note that the potential downfall of the Big Bang theory hasn't received widespread attention in mainstream news outlets. The lack of widespread attention to recent challenges to the theory of the universe's origin can be attributed to what's known as the Emperor's New Clothes effect, where questioning the theory often leads to scientists being criticized or labeled as unintelligent, which can stifle further exploration of alternative theories. The cyclic universe model, in particular, might offer an explanation for the new galaxies that have been detected. these galaxies might be part of another cycle that we've observed. However, it's essential to note that these alternative theories have their own complexities and challenges, and the scientific community continues to explore and debate these ideas. The quest for knowledge and understanding in cosmology involves ongoing exploration and consideration of various theories, and open discussions are essential for advancing our understanding. As we delve deeper into the universe's mysteries, the tools we use to explore it become increasingly refined. The James Webb Space Telescope, with its advanced capabilities, offers a new lens through which to view the universe, shedding light on aspects of cosmic development and evolution that were previously shrouded in mystery. One of the key advancements brought by Webb is its ability to observe galaxies in different stages of development and at different points in time, providing a more nuanced view of their life cycles. Recent observations suggest that the early universe may have been more complex than the Big Bang theory initially proposed. For example, Webb data shows that some of the newly discovered galaxies seem to have formed much earlier than expected, challenging our understanding of the universe's grand timeline. This evidence pushes the boundaries of current models and forces scientists to consider alternative explanations for these findings. Another intriguing angle is the discovery of primordial black holes. These theoretical objects, which could have formed in the early universe, may help explain some of the unexpected characteristics observed in distant galaxies. If these black holes exist, they could have a significant impact on the formation and evolution of galaxies, introducing new factors into our understanding of cosmic development. The enhanced resolution of Webb's observations also allows scientists to study the formation of stars and planetary systems in unprecedented detail. By analyzing the light from these distant stars and the surrounding gas and dust, researchers can gain insights into the processes that govern star formation and the birth of planetary systems. This information is crucial for understanding how conditions for life could arise in other parts of the universe. These new discoveries challenge what we once thought were irrefutable truths. Neil deGrasse Tyson has become a significant figure in this evolving universe of science. Now, something exciting is happening with the James Webb Space Telescope. It's remarkable, something that could make us question the theory of how things came to be. The James Webb Space Telescope has found 750 new galaxies. These galaxies are different from what we expected, leading us to reevaluate what we thought we knew about them. This telescope was designed to help us understand how galaxies formed, so it's not surprising that it's shaking up our understanding of the universe. In the past, scientists said that the Big Bang theory was the best explanation for how the universe began. According to this theory, around 13.8 billion years ago, the universe appeared through a mysterious cosmic event, like the dramatic story of the universe's birth. However, the images from the James Webb Space Telescope have challenged this idea. These images show galaxies that are smaller, smoother, older, and more numerous than what the Big Bang theory predicts. According to the theory, as the universe expands, objects should look larger the farther away they are. However, these galaxies do not follow that rule. The theory also states that at the very beginning of the universe, all the matter that makes up the universe was compressed into a tiny, superdense point called a singularity. This singularity was extremely hot, hotter than anything we could measure or create. This idea of a singularity comes from a set of equations in physics proposed by Albert Einstein, called general relativity. Inside the singularity, all the matter in the universe was packed into a tiny space with super high density, meaning there was an enormous amount of mass energy pressed into a little space. So, in simpler terms, researchers have consistently said that the theory of prehistoric cosmic detonation was how the universe began. However, these new pictures from the James Webb Space Telescope are making us question that idea. The cosmic systems it found don't fit with what the hypothesis anticipated, and the hypothesis explanation of the early universe might not be as certain as we thought. In our current understanding, we believe that all the energy in the universe started from a very hot and very dense point called a peculiarity. This peculiarity is like the starting point for everything we find in the universe today. After this peculiarity, the universe began to expand and grow over the course of about 13.7 billion years to become what it is today. The development started with something called fast expansion, where the universe grew at an incredibly fast rate, even faster than the speed of light. It was as if the very fabric of space itself was expanding, and everything in it was expanding along with it. This vast expansion helped shape the universe by making things more uniform, setting the stage for the formation of cosmic systems, stars, and other structures. As the universe continued to expand, it didn't expand as quickly as during the fast expansion but still kept growing. We call this ongoing expansion enormous extension. Researchers have observed evidence of this expansion through phenomena like how light from distant galaxies shifts in color, a process known as redshift.